Last episode, we gave the brain in a jar a pair of hands. We described tools to it, and a wrapper program ran them. But we ended on a quiet problem that turns out to be enormous. Every one of those tools had to be wired up by hand. And if you ever wondered why, for a while, your AI assistant could talk to almost nothing you actually used, this is the reason. Today, we meet the idea that fixed it. And it is less about intelligence and more about plumbing, which it turns out is exactly what was missing. Picture the world just before this idea. You have many different AI applications and thousands of services people want to connect them to. Your email, your calendar, your company database, your code. For an assistant to use one service, an engineer had to write a special piece of connecting code custom-built for that exact pair. One assistant, one tool. Now multiply it. Every AI app times every service, each needing its own bespoke connector, written and maintained separately. A mess that grows by multiplication, and most tools simply never got connected at all. If this smells familiar, it should, because the world solved this exact shape of problem before. Think how many devices once had their own incompatible charger. Then a single connector arrived, and one shape fit everything. Or think of the wall socket. The power company does not know or care what you plug in. A lamp, a laptop, a fridge. Everyone simply agreed on the shape of the hole. That agreement, that shared shape, is called a standard. And standards are quietly one of the most powerful ideas in all of technology. So here's the idea. And the whole episode is really just this one sentence. What if there were a universal standard for how any AI application talks to any tool? That standard exists. It is called the Model Context Protocol, shortened to 3 letters, MCP. Let us take the name apart because it is honest about what it does.
Model, the AI brain. Context, the information and abilities from the outside world you want to give it. Protocol, an agreed set of rules for how the two talk. A protocol is nothing more than a shared language, the handshake both sides promise to speak. Here is how it reshapes the mess. Instead of each AI app writing a private connector for each tool, everyone agrees to speak this one protocol. A tool provider builds one thing, called a server, that describes what the tool can do in this shared language. Any AI application that speaks the protocol can now use it with no custom wiring at all. Suddenly, it is not every app times every tool. It is each tool exposing itself once and each app learning the protocol once. Multiplication collapses into simple addition. Let us make the two sides concrete because the words matter. The tool side runs a server. Do not picture a giant machine. It's just a program, and it can be tiny. It might run on your own laptop to give the AI access to your files, or in the cloud to connect a giant service. Its whole job is to announce, in the shared language, here is what I offer, and here is how to ask for it. The AI side runs a client, which lives inside the assistant and knows how to speak the protocol to any server it meets. Now, pause the video because there's a beautiful consequence hiding here, and you might already see it. When a new tool is invented tomorrow, how much work does it take to make every AI assistant in the world able to use it? In the old world, a fresh connector for each one. In this world, the tool builder writes a single server once, and every assistant that speaks the protocol can use it immediately without being updated at all. The tool and the model no longer need to know anything about each other in advance. They only need to share the language. A brand new tool labeled Just Invented, plugging into the central MCP bar and instantly lighting up connections to many different AI assistants at once, headed Build Once, Works Everywhere. And this is exactly why you may have watched your AI assistants suddenly become far more capable in a short time. It was not only that the models got smarter, it was that a shared standard let them plug into the real world all at once, instead of one painstaking connector at a time. A whole ecosystem could grow because everybody was finally building against the same socket. That is the quiet difference between a clever demo and a technology that actually spreads. Now, the honest part. Because a universal standard is not free. The moment you let a model reach into your real tools, your files, your email, your ability to spend money, security stops being optional. A connector that can act on your behalf is exactly the connector an attacker would love to trick. So a serious part of this idea is not the plumbing, it is the permission. Who is allowed to connect? What may they touch? And how do you ensure a tool only does what you actually approved? A standard that hands out real power has to hand out real caution with it. And a second honest point. A standard is only as useful as the number of people who adopt it. A socket shape nobody builds for is worthless. What made this one matter is that it did not stay the property of a single company. It became a shared, open standard that competing companies agreed to support together, which is the only way a plug ever truly becomes universal. The agreement is the technology. So here is the big picture. An agent needs tools, but wiring every tool to every AI by hand grows into an impossible tangle. The Model Context Protocol is a shared language, a universal socket that lets any AI application talk to any tool. Tools expose themselves once as a server, assistants speak the protocol once as a client, and the whole tangle of multiplication collapses into simple addition. Build a tool once, and every assistant can use it. That is how AI stopped being a clever mind trapped in a box and started becoming something plugged into the world. So we now have a model that can hold a conversation, look things up, and act through tools. But through this whole series, one thing has quietly bothered careful viewers. When a model answers a hard question well, is it actually reasoning or just producing text that looks like reasoning? And recently, something changed in how these models tackle hard problems, something that genuinely improved them. That's next time when we watch a model learn to think before it speaks.